Welcome back to Low Stress Math with Mrs. Bono. We are in Unit 5, Writing Linear Functions, Lesson 6, Graphing, Applications of Graphing. So, let's take a look at this problem. Example 1, a tank of water that is completely filled. That's kind of important. So you know what? I think I'm going to underline that. Completely filled. Ooh, has a leak. What does leak mean? It means there's water coming out of my tank. I'm not really loving this picture, but it is a tank and there is water, and this guy is kind of weird with no shoes, but whatever. The graph below shows the volume of water, gallons, and here is volume, and GAL is an appropriation for gallons. And this V is a typo. It's supposed to be a Y. So I'm just going to kind of change it to a Y. And time. Time is across the bottom, as always, the X variable. It's been a long time since I've seen time not be the X, but we'll get back to that. Volume of water in an industrial water tank. Industrial, that gives me a hint that this is a pretty big tank of water, right? What is the independent variable? Oh my goodness gracious, I don't remember what that means. So I have to come all the way back. Oh dear, where am I gonna find it? I gotta flip through all my papers. What the heck? Okay, here it is. It's on page, I don't remember. And I think I wrote over it. What page am I on? Page 21. Independent variable, X value, input domain, almost always time. I knew that time was gonna be important. Time is X. Dependent variable, Y value, output, range, and it really depends, that's why it's a dependent variable, on the X values. So let's get back to that independent practice. And right here, along the X-axis is time. What is the independent variable? Almost always time. So here, we're gonna put it X, time, and parentheses minutes. What is the dependent variable? Y, volume, and we'll put the parentheses gal. And not gal like a girl, gal like a gallon. All right, what is the vertical intercept? Ooh, we talked about this before. Vertical intercept, here we go. I am going to write that right here. Vertical intercept, it's a little small, let's make that bigger, is the y-intercept. It's the same thing. If you don't remember, you can always flip back in your notes to find it. So what is the y-intercept? Well, first, I'm gonna grab my yellow highlighter to highlight the y. You know, y is for yellow. And here is the y. And here is the y-axis. And intercept is right here where it intersects, almost the same word, at 250 gal. So B equals 250. That's going to be important in a little while. But what does this tell us about the situation? Oh, I didn't show it. What does this tell us about the situation? It's at the beginning. The y-intercept is always the start of it. So let's write that down. What does this tell us about the situation? Well, wait a second. A tank of water that is completely filled. Completely filled. All right. The y-intercept, or vertical intercept, whatever they want to call it. I like y-intercept better. The y-intercept, 250. And now this is where it's really important to look at the units. It's in gallons. The y-intercept, comma, 250 gallons is the water in the tank when it is full. So, units matter, and it tells you a lot about the situation. What is the rate of change? Ah, I know what that means also. So rate of change, I'll make myself one of those little things, that's the slope. And the rate of change, the slope here, is going to be m equals rise over run, because this is a graph. So let's take a look at the rise and the run. Units matter. Look over here. To get from 0 to 50, that one box is 50. 2 boxes is 100. 3 boxes is 150. 4 boxes is 200. And 5 boxes, and that's what I'm going to do because 5 boxes is 250. That's my rise. Now I'm going to run, but I'm turning left. My run is going to be 10, 20, 30, 40, 50. My run is 50. And that's going to the left, so it's negative. Run left is negative. So rise over run, 250 over negative 50. So 250 over negative 50. Wait a second, I can reduce that. M equals 250 divided by 50 is 5. So that's important, m equals 5. But what does it tell us about the situation? That's a different kettle of fish altogether. And in order to get that, again, I need to look at the units. I have minutes and gallons. I have rise over run. Rise is y, run is x. As a matter of fact, I'm even going to write that. It's y over x. Rise is y, run is x. So 5 over what? It would be 5 over 1. 5 what over what? 1 what? 5 gallons over 1 minute. What does that tell us about the situation? It's negative, which I forgot to put over here because I am foolish. It's negative because it's the water leaking out of the tank. This is the rate. This is the rate that the water leaks out of the tank. Again, I'm going to use the units when I write it down. -5 gallons per, which means for 1 minute. -5 gallons per minute. That's the water leaking out of the tank. All right, write a linear function. Well, I can do that. Y equals, m is the slope, x plus b is the y-intercept. So I need to keep the y and the x and replace the m with -5 and the b with 250. So y equals -5 x plus 250. And that is the puffy cloud of happiness, my equation. Puffy cloud of happiness. That is beautiful. All right, let's take a look on the next page. Should go a little faster for the rest of the problems because now we kind of know what we're doing, right? Independent variable. Do I have any time? Yes. Oh, I didn't read the problem, silly me. Your favorite musician is performing for your birthday party. Yeah, raise the roof. Okay, don't do that. The graph below shows the amount of money it will cost to rent the concert hall in dollars and the amount of time the hall is rented in hours. Okay. So here's the cost, which they use C, but you know what? I'm just going to put a little y here because I know that's the y. And here's the time, which they use T, but I know that that's the X. And I just highlighted both of them, and that was silly of me, wasn't it? Because I really only wanted the Y. And look at this. There's my Y-intercept. Haha, I'll get back to that in a minute. Independent variable is almost always time, the X. What's the independent variable? Time, X, time in hours. Or T, but I don't like the T, so I'm gonna use X. What's the dependent variable? That has to be the other one. The cost, because the cost depends on how long you rent the hall. So Y, cost, and that's in dollars, or they're using the letter C for cost. What's the vertical intercept? It's where we start. B equals 100. 100 what? $100. So what does that represent about the situation? Well, that's how much it cost before I pay for anything else. That's 0 hours. That's a down payment. When you're going to rent a hall, you have to give them a down payment so that they'll hold the hall. And the longer you stay there, the more money it's going to cost you. So $100 is the cost before the concert starts. That's just the beginning cost. Now, what is the rate of change? Well, M is rise over run. And what do I have here? Oh golly, look at how horrible these points are. None of them seem to be intersecting very well, except this one. So what's my rise? Well, each box is worth 100. So 100, 200, 300, 400, 500. My rise is 500. And the run, 1, 2, 3, 4, 5, 6, 7, 8 hours. So $500 is the rise, 8 hours is the run. Rise over run, 500 over 8, which I could reduce down by using my handy dandy calculator. Hello, Ty, how are you today? 500 over 8 is 125 over 2, or 62.5. That's kind of what I want to use, 62.5, because it's money. 62.5. And because it's money, I'm adding that 0 to get $62.50 per hour. So dollar signs and per hour. What does that tell us about the situation? That's the cost of the hall per hour. So how am I going to write this as an equation? Well, I need these two pieces of information. I need the B is 100, and I need the M, which is 62.5. And I only have to change it to 0.50 when I'm writing it as dollars. If I'm just writing it as part of the equation, I don't have to do that. So what's my equation? Y equals mx plus b. So y equals 62.5 x plus b 100. And I just realized this decimal is not very good. Make that a good decimal. So how much will it cost? How much will you pay if the concert is rented for 4.5 hours? Well, I'm going to need my equation. Y equals 62.5x plus 100. And 4.5, is that an x or a y? Think about it. It's x. X is the independent variable time. And when it says hours, you know it's time. So y equals 62.5 times 4.5 hours plus $100 deposit. So, yeah, bring back that calculator, Bono. You're not multiplying 62.5 times, yeah, no, that's not going to happen. Times 4.5 plus 100. Up, $381.25. Ba-bam. Y equals $381.25. So now I have to write a sentence because you know how that works. The cost of the haul for 4.5 hours is $381.25. Ta-da. All right, let's take a look at the next one. Irene wants to make a phone call to her friend while on vacation. She finds a payphone that charges a fee based on the number of minutes she spends on the phone. The graph at right shows the amount of the fee and the time of the phone call in minutes. So to start the call, it's going to cost her 3 cents. And then, every minute it's going up. Now be careful because it's going up 3 cents. So my rise is 3 cents. As always, independent variable, X for time. Well, they're using T and F, X, time in minutes. And the dependent variable, Y, which is the fee in cents. And they're using F for fee. What is the vertical intercept? I already looked at it because that's me. Here's the vertical line. The intercept is 3. So what's the vertical intercept? B equals 3. It's actually what? 3 cents. 3 cents. And what does that tell us about the situation? That's the cost before the call starts. Or if you want to say that's the cost to start the call, you could write that too. Anything that says that that is the beginning of the equation, that's the beginning of the graph, that cost. All right, so what is the rate of change? Rise over run, thankfully. So M equals rise over run. And now, again, they gave us this silly graph where it's not at a cross, it's not at a cross, it's really not great until I get here. But remember, each box is worth 3. So 3, 6, 9, 12, 15. My rise is 15. Don't tell me it's 5. It's 5 boxes, but it's 15 cents. And then the run going across, the run is 6. So rise over run, 15 over 6. Now you could reduce that to 5 over 2, which really means it costs 5 cents for 2 minutes. So after you start the call, the cost is 5 cents for 2 minutes. Now, if you reduce that down to 2.5 cents per minute, that's fine too. but just make sure you're using the units. It's absolutely vital to use the units. All right, let's write a linear function to describe the situation. So I have b equals 3, and m is 5 over 2. So y equals 5 over 2x plus 3. How much will Irene pay for the fee if her phone call is 9 minutes long? Pfft, I wish I could come over here and find 9 minutes and just go up on the graph, but I can't. So 9 minutes, is that an x or a y? Oh, it's minutes, it's time, it's x. So y equals 5 over 2 x plus 3. Y equals 5 over 2, and I'm using 9 for x, plus 3. And now grab my handy dandy calculator, because you know how I feel about fractions. The icky, 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 icky. 5 over 2 times 9 plus 3. 51 over 2, double arrows, 25.5. So y equals 25.5 cents. But you can't really do that, can you? Nah. You can't have 0.5 of a cent. So you really have to round that. And you know, because it's the phone company, you have to round that up to 26 cents. So in reality, it's going to cost her 26 cents for 9 minutes. Okay. Last problem. Ugh, look at that hot mess. There's 2 things here. All right. Ricky and Aaron both have a coin bank. Starting in January, they both had different amounts of money in their banks. Throughout the year, they plotted the amount of money they saved. The graph to the left shows the amount of savings, S, in each bank after T months. You know me, I'm going to come over here and I'm turning this S into a Y and this T into an X, which as long as you do that, as long as you write it on the graph and put it down in the directions here, it's fine. You're allowed to change the variables. I'm giving you permission. It's all right. And what's the independent variable? As always, time. And how much time in Mo? Well, you know Mo stands for months. So time, and I'll use their abbreviation, but I know it means months. And the dependent variable is savings, and that's going to be in dollars. All right, what is the initial amount of money each boy had in their coin bank? Initial amount, that's a starting amount. We talked about all the words that mean in the beginning. So the initial amount is what they started with. So let's follow Ricky over here, and he had $30. So Ricky had $30. And what about the other boy, Aaron? Aaron only had $10. Now, how much money did Ricky save per month? Let's rise over run. Each box here is worth 10. So, let's see, 10, 20 in 1, 2, 3, 4, 5 months. So Ricky has, what did I just say, $20 in 5 months, which is $4 per month. What was this amount the same each month, and why? Ooh, that's a tricky question. Yes, it is the same amount each month because the line is straight. It's the same each month because the line is straight. How about Aaron? What did Aaron save each month? Well, he got $10 in 2 months. His rise is 10, his run is 2. So Aaron is 10 over 2. That's pretty good. He saved more money, didn't he? Yes, he did. He is $5 per month. Was this the same each month? Yes, it was. It's still a straight line. Yes, it is a straight line.
At this time, seventh graders, please move to your fourth period class.
Who saved more money each month? Aaron, because he has a larger slope. Go, Aaron. Okay, have a great day. I will talk to you soon. Bye.